Hi, this is an example problem for week 1, chapter 18. Pause for a moment and read the question. So in this problem, we've got 3 metal spheres that each have a given charge. We're going to bring them together and we're going to ask what is the net charge in part A on the spheres while they're in contact. So in part A, we are basically looking at, some spheres. They're metal, and they've all got a different amount of charge on them, right? We've got plus 1.17 microcoulombs. And then we're going to go ahead and take another of these and we're going to put them together. So we got 3 spheres. They're all in contact. This one's plus 6.02 microcoulombs. This one is minus 4.64 microcoulombs. But once we put them in contact, since they're metal, they're conductors, the positives and the negatives are going to go ahead and combine and neutralize one another. How do we figure this out? Well, we just go ahead to get the net charge that's on all of these while they're in contact. We just add together all the charges. The plus and minus signs naturally will cause the neutralization of positives with negatives, and then we'll be left over with just one type of charge. We'll see in this case it's going to be positive since there's more positive than there is negative. So our net charge here, it's plus 1.17 microcoulombs plus 6.02 microcoulombs plus, in this case, got a negative 4.64 microcoulombs. When we put that into the calculator, we get an answer of plus 2.55 microcoulombs. And we know that there is a excess of protons now because it's a positive charge. For part B, what is the final charge on each sphere after they are separated? Well, since these spheres are identical and the positive charges want to get away from each other as much as possible, the charges will shift around until they're equally divided between the 3. So to get the final value on each of the spheres, we just take the net value in this case and divide by the number of spheres. And we're going to get an answer here, which is equal to positive 0.85 microcoulombs. Now in part B, in part C, we are asking how many electrons or protons make up the final charge on each sphere. Well, we know that these are protons because it's positive. So let's take the total charge on one sphere. So this is our charge on one sphere, 0.85 microcoulombs. I'm not going to bother writing the plus sign. We just, if it's not negative, we assume it's positive. And now I need to do a unit conversion. Essentially, I'm going to go ahead and convert between charge and protons. We have, let's see, for each proton, we know that each proton has a charge equal to 1.6 times 10 to the 19th coulombs. We're almost there. We just got to figure out what to do with this microcoulomb. Well, we remember that microcoulomb, that is equal to 10 to the minus 6th coulombs. So we've got that, and then we just continue. Ooh, I found a mistake there. It's supposed to be minus 19. All right, cancel out our coulombs. We'll be left with protons. Let's see what this comes out to. We end up with 5.31 times 10 to the 12th protons. So we can see that it takes a lot of protons to make up, some microcoulombs of charge there, because on a proton there's such a small amount of charge on each.